Welcome to Algebra 1, Unit 6, Lesson 13, Practice Problems. Here are four graphs. Match each graph with the quadratic equation that it represents. So as we look at the functions, choice number 1, we have y equals x squared plus x. What I'm going to do is I'm going to factor an x out of both of these terms. And this changes it from a standard form into a factored form. Because x squared divided by x is x, and x divided by x is 1. So now that I have my factors, I know that x equals 0 and x equals -1. So this is going to match with a graph where I have x-intercepts at 0 and -1. And I can see that right here and here on graph A. So graph A matches equation 1. Number 2. This one, what I want you to notice is we have the negative. So the negative flips upside down, and the +2 shifts up 2. And the only one we see that is flipped upside down is C, and we also see that the vertex has shifted from the origin up 2 units. So that means graph C matches equation 2. Equation 3. We see x squared minus x. Again, I'm going to factor out an x to change it from standard form to factored form. X squared divided by x is x, and negative x divided by x is -1. This means my x-intercepts are going to be x equals 0 and x plus 1. So if we look at our graphs, we see that in graph D with an intercept at the origin and an intercept at +1. That means graph D matches equation 3. And finally, equation 4, we see x squared plus 3x. I'm going to factor an x out of each term. X squared divided by x is x, and 3x divided by x is 3. Now I know that my x-intercepts are x equals 0 and x equals -3. And we see that on graph B at the origin and at -3. So that means graph B matches equation 4. If you have any questions about how I matched the graphs to the equations that represent them, Please use class time to ask for further clarification. Complete the table without graphing the equations. So on our first one, I'm going to factor out an x. X squared divided by x equals x, and 12x divided by x equals 12. If x is my factor, then my x-intercept is 0, 0. If x plus 12 is my factor, then negative 12, 0 is my x-intercept. The x-coordinate of the vertex is halfway between those intercepts. Halfway between 0 and negative 12 is negative 6. Next, again, I'm going to factor out an x. X squared divided by x equals x. Negative 3x divided by x equals negative 3. If x is my factor, then x equals 0, and my intercept is at the origin. If x minus 3 is my factor, then x equals 3, and my intercept is at 3, 0. The x-coordinate of the vertex is halfway between the two intercepts. Halfway between 0 and 3 is 1.5. Next, I'm going to factor out an x. Negative x squared divided by x is negative x. And 16x divided by x is 16. If x is my intercept, or x is my factor, then my intercept is at the origin, 0, 0. If negative x plus 16 is my factor, then x is 16, and my intercept is at 16, 0. Halfway between the origin and 16, 0 would be 8. And number 4, I'm going to factor out an x. Negative x squared divided by x is negative x. And negative 24x divided by x is negative 24. If x is my factor, then my intercept is at the origin. If negative x minus 24 is my factor, then x is negative 24, and the intercept is at negative 24, 0. The x-coordinate of the vertex is halfway between the origin and negative 24, which would be negative 12. If you have any questions about how to change standard form into factored form to find the x-intercepts, or how to use the x-intercepts to find the x-coordinate of the vertex, please use class time to ask for further clarification. Here is a graph that represents y equals x squared. Describe what would happen to the graph if the original equation were changed to y equals x squared minus 6x. Predict the x and y intercepts of the graph and the quadrant where the vertex is located. So if we want to find the x-intercepts, then I can factor out an x. X squared divided by x equals x. And negative 6x divided by x equals negative 6. So my x-intercepts, if x is my factor, then my intercept is at the origin. And if x minus 6 is my factor, then my intercept is at 6, 0. If I want the y-intercept, then my x values are 0, and I have 0 squared minus 6 times 0, which is 0. And my y-intercept is going to be at the origin. If we want to know what quadrant this is going to be in, remember that we start with quadrant 1 in the upper right, and then we go counterclockwise. So quadrant 2 is the upper left, quadrant 3 is the bottom left, and quadrant 4 is the bottom right. I would need to shift this graph down and to the right to have these x-intercepts. So graph will shift down and right, putting the vertex in quadrant 4. And number 2 wants us to sketch the graph of this. So, we already said the x-intercepts are going to be at the origin and at 6, 0. And we said the y-intercept was also at the origin. So I need to know where the vertex is. Well, the vertex x-coordinate is halfway between 0 and 6, which would be 3. So it's somewhere along this line here. But I need to know the y value. So I take my original equation and I substitute 3 in for x. 3 squared is 9. And negative 6 times 3 is negative 18. 9 minus 18 is negative 9. So my vertex is at 3, negative 9. Now I can place my point for the vertex, and I can draw my parabola that represents it. And this is y equals x squared minus 6x. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Select all equations whose graph opens upward. To determine whether the graph opens upward or downward, we need to look at the x squared term. If x squared is positive, the graph opens up. If x squared is negative, the graph opens down. So now we're going to look at these. This a has a negative x squared. So it opens downward. B has a negative 5x squared. This opens downward. In C, we're going to change it to a standard form. So this becomes 2x minus 1 times 2x minus 1. And using the FOIL method, 2x times 2x is 4x squared. 2x times negative 1 is minus 2x. Negative 1 times 2x is minus 2x. And negative 1 times negative 1 is plus 1. When we combine the x terms, we have 4x squared minus 4x plus 1. The 4x squared is positive, so C is one of our answers. It does open upward. Choice D, using the FOIL method, 1 times 2 is 2. 1 times x is x. Negative x times 2 is minus 2x. And negative x times x is negative x squared. When we combine the x terms, our final answer is negative x squared. X minus 2x is minus x. And we have plus 2. The x squared term is negative x squared. So this opens downward. And choice E, we have an x squared, which is positive, so E also opens upward. If you have any questions about how to tell whether a graph will open upward or downward, please use class time to ask for further clarification. Write an equation for a function that can be represented by each given graph. Then use graphing technology to check each equation you wrote. So in graph 1, notice we have x-intercepts at -7 and 0. If I were to write factors, then that could be x plus 7, because then -7 plus 7 would be 0, and x, because at the origin x is 0. So I could write it this way in factored form, or I could distribute it and write x squared plus 7x in standard form. Graph 2. We can see x-intercepts at -4 and +4. And we can see a y-intercept at -16. If I have an x-intercept at -4, I know that that is x plus 4, because -4 plus 4 equals 0. If I have an x-intercept at +4, then that would be x minus 4, because 4 minus 4 is 0. So this would be the factored form of the expression, or I could use FOIL and I would get x squared plus 4x minus 4x minus 16, which becomes x squared minus 16, and that would be a parabola with its vertex at the origin shifted down 16 units. And graph 3, we can see an intercept at -9 and at +3. If my intercept is at -9, then I know my factor is x plus 9, because -9 plus 9 equals 0. If my other intercept is at +3, then I know my factor is x minus 3, because 3 minus 3 is 0. This is the factored form. I could also use FOIL to write it in standard form. X times x is x squared. X times -3 is minus 3x. 9 times x is plus 9x. And 9 times -3 is minus 27. When we combine the x terms, our standard form is x squared plus 6x minus 27. So these are the standard and factored form equations that would represent these graphs. And if you would like to check them, you can put them into the Desmos.com calculator and compare them to the graphs that were given. If you have any questions about anything covered on Lesson 13, please use class time to ask for further clarification.